Hello and welcome to this video about how a hologram is made. In this video the process of how to make a hologram on an optical table is explained. I've used that particular setup because it is what I have experience of. An optical table is nothing more than a heavy steel table on which it is possible to mount and fix optical components. Some top-end tables will have a damper mechanism. The damper mechanism helps reduce extraneous vibrations from reaching the optical components. I've put a link below this video to a typical example of an optical table. I have no association with, nor am I sponsored by Newport. Newport was just one of the first links that appeared in a search of the web. So the first image you can see shows the typical components that will be used on an optical table to make a hologram. The laser would typically be a laser diode. The purpose of the spatial filter, as the name suggests, is to filter the laser signal. How does it do this? Before specifying the how, we need to consider the why. The laser signal will have a significant amount of noise at its edges. We want to eliminate this noise. In fact, all we can do is reduce it. You can never get rid of noise. So we can eliminate or reduce this noise as it would affect the hologram. How is the noise eliminated? Or should I say restricted? Well, the technique used is that of physical blocking. The spatial filter is simply a hole in a suitable piece of optical material, and that hole has to be smaller than the laser beam's diameter. A simple spatial filter would just, as I mentioned, be a hole, but more advanced devices will have a microscope lens. Again, there's a link below which goes to one of the Newport spatial filters. BS stands for beam splitter. This device transmits half of the beam and reflects the other half of the beam, hence the term 50-50. Again, there's another link below. The mirror is simply a mirror, and that just reflects all of the light that's hitting it. In this second or updated image you can see light paths. Those are coloured green. The laser signal is split into two as just described. The light path from the beam splitter to D1 is known as the object beam, and that from the mirror is known as the reference beam. The object beam enters D1 and the reference beam enters D2. D1 and D2 are diverging optics. They consist of a series of lenses, which I'm not going to go into the detail here because the video would be too long. However, I will probably go into more detail on these devices in a later video. In this image you can see how the diverging beams emerge from D1 and D2. The beam from D1 strikes a 3D object. Now this is the object of which a hologram is to be made. The beam from D2 strikes what I've shown here as either a photographic plate or an image sensor. For the ease of understanding, for the time being, I'm going to stick with the concept of a photographic plate. The complete and final setup can now be seen. You will note that there is an addition of a red light path. This is the signal reflected from the object towards the photographic plate. So what then is a hologram? Well, the 3D object has a surface profile. The surface profile is just a series of depth changes. That profile will induce changes of phase in the object beam. At the photographic plate, the object beam mixes with the reference beam. They interfere. This interference produces fringes on the photographic plate, and those fringes can be seen when the plate is viewed. To retrieve the hologram, you would have to illuminate the photographic plate with the reference beam, and then a holographic image would appear behind the plate. The process of interference can be seen in the equation, which is now being shown. The final consideration we need is the image sensor. Clearly, you cannot simply illuminate the image sensor to get a hologram. You have to subtract the reference beam in software, and the hologram would then be in memory. So that concludes this short video on holograms. I hope you have learnt something from it. It would be very useful if you'd consider subscribing, and thank you for watching.